Hello, and welcome to the first in the series of videos that we're giving on the equipment that the AMCASH project has and how it can help small businesses. The first in this series is differential scanning calorimetry, which is commonly known as DSC. In basic terms, DSC measures the changes to material on heating and cooling, such as softening, melting, crystallization, and curing. This can be used to determine the temperature at which changes occur, the energy involved, and also the crystallinity of material. So why is this information useful and how can it be used to help your business? Well, firstly, if we know the softening or melting point of a plastic, we can use this information to determine the optimum processing conditions to use. This ensures that the material is fully liquefied, but that elevated temperatures aren't required. In addition, if a material is going to be used within a set temperature range, we can determine that it's thermally stable throughout this process. DSC can also be used to aid identification of plastics. Different plastics will have different melting points and glass transition temperatures, and through this we can determine which material is present. Crystallinity is an important parameter that we can determine by DSC as it impacts on the mechanical properties of material. In addition, we can look at the crystallization kinetics to determine how you can alter your process to control the crystallinity. We can also replicate the manufacturing process. For example, if multiple heating and cooling steps occur, we can use this to determine the crystallinity that will be produced in the final material. We can also look at the curing characteristics, for example, the time, duration, and energy. In addition, we can look at the miscibility of two polymers and also the effect of additives on the thermal properties of a material. So how does DSC work? If you look at the right-hand photograph, you'll see a small aluminium pan. We place the sample inside this pan and seal it with a lid. We also use a blank pan and lid as the reference. As you can see from the diagram on the left, we place the sample and the reference into the DSC. The machine then provides energy to heat these pans at a set rate. When a thermal transition happens, such as melting, energy is required. This reduces the temperature increase of the sample, and as a result, more energy must be supplied. The DSC measures the difference in the heat flow to the two samples and reference and uses this to monitor transitions. A typical example of an experiment can be seen on this graph. As we heat the sample, we can see the glass transition temperature and the melting point, and can determine the temperature of each of these transitions. As the sample is cooled, we can then see the crystallization point. If we take the area of the melting point, we can then determine the crystallinity of our sample. In the AMCASH project, we have two different DSCs. The first is the Mettler-Toledo DSC1. This can perform over a temperature range of -80 degrees up to 450 degrees. It performs both heating and cooling cycles at a rate up to about 50 degrees per minute. The sample we use is typically between 3 and 10 milligrams. We also have a flash DSC. This is used as a chip to rapidly heat and cool the samples, and this prevents recrystallization and heating, producing a more accurate result of the material present. It can also be used to mimic processing conditions. The flash DSC can operate at a temperature range between -80 degrees C and 450 degrees C, has a heating rate of up to 20,000 degrees per second and a cooling rate of about 5,000 degrees per second. We thank you for watching this video, and if you'd like any more information on the AMCASH project, please visit www.amcash.co.uk. Thank you for listening.